Black holes have an inside, a region beyond the event horizon, where matter falls to the singularity, where time and space flip roles, where nothing escapes. Every physics book says this. Every documentary shows it. Leonard Susskind says it's completely wrong. There is no inside. Never was. Never will be. The entire concept of interior is illusion. And proving this required him to fight Stephen Hawking for 30 years. Imagine falling into a black hole. You cross the event horizon, the point of no return. Once you're past it, you're inside, trapped, doomed, falling toward the singularity. This interior region exists. It's real. It's where you go when you fall in. Leonard Susskind says stop. That picture is wrong. Fundamentally, completely, dangerously wrong. There is no inside. The event horizon is not a boundary you cross into an interior region. It's the only thing there is. There is no beyond, no other side, no interior space. You fall in, and you never leave the horizon. You never enter an interior. You stay on the surface, spread out, encoded, holographically, forever. Your entire journey into the black hole happens on a two-dimensional surface, not in three-dimensional space, not in an interior, on the horizon, flat, two-dimensional, holographic. This is black hole complementarity, Susskind's answer to the information paradox, his 30-year battle with Stephen Hawking, his proof that black holes don't have interiors in the way we think, that inside is an illusion, a perspective, a description, not reality. Let me show you how he proved it. Start with the Hawking information paradox. In 1974, Stephen Hawking discovered that black holes radiate, they emit thermal radiation, they have temperature, they glow, incredibly faintly, but real. This radiation causes the black hole to shrink, lose mass, evaporate. Eventually, given enough time, trillions of years, the black hole disappears completely, radiates away, gone. But here's the problem. When matter falls into a black hole, it carries information, the quantum state of every particle, the arrangement of atoms, the pattern of energy, information, quantum information, which is conserved in quantum mechanics, always, no exceptions, never destroyed. So when the black hole evaporates, where does the information go? It must come out in the radiation, must be encoded in the Hawking particles, somehow. But Hawking's calculations said no. The radiation is thermal, random, maximum entropy, no information, pure noise. This means information is destroyed, gone, lost forever when the black hole evaporates. Violation of quantum mechanics, fundamental law broken, catastrophe for physics. Hawking said quantum mechanics must be wrong, must be modified. Information can be destroyed in black holes. This is new physics, beyond quantum mechanics. Susskind said no, absolutely not. Quantum mechanics is sacred, cannot be violated, not even by black holes. The information must be preserved, must come out, somehow. We just don't understand how yet. This launched the black hole war. Susskind versus Hawking, 30 years, fighting over the fate of information, over the foundations of quantum mechanics, over the nature of reality itself. Susskind's insight was complementarity, the idea that different observers see different but compatible descriptions of the same physics, like wave-particle duality. Light is both wave and particle depending on how you measure it. Both descriptions are correct, both are real, neither is more fundamental. Apply this to black holes. An observer falling into the black hole sees one thing. An observer staying outside sees something completely different. Both descriptions are correct, both are real, but they're incompatible. Can't both be literally true, yet both must be true. The falling observer crosses the horizon smoothly. Nothing special happens, no drama, just continuing inward, falling toward the singularity, eventually reaching it, being destroyed. This is the classical general relativity picture. Einstein's equations say this happens. The outside observer sees something different. The falling observer approaches the horizon, slows down, time dilates, red shifts, appears to freeze at the horizon, never quite crosses. The image fades, red shifts to invisibility, but never disappears into interior, stays at the horizon, forever. Both observers are right, but how? If the infalling observer crosses the horizon, how can the outside observer see them stay at the horizon? If they stay at the horizon, how can they experience crossing it? Susskind's answer shocked physics. There is no contradiction because there is no interior, not in the fundamental description. The interior is observer-dependent, perspective-dependent. The falling observer experiences interior because they're using coordinates where interior exists. The outside observer doesn't see interior because they're using coordinates where only horizon exists. Neither description is more real. Both are valid. Both are consistent with quantum mechanics. But they describe the same information, the same degrees of freedom, just organized differently, represented differently. The key insight is holography. The maximum information that can be stored in a region is proportional to the area of its boundary, not its volume. Area. This is the Bekenstein-Hawking entropy formula. Entropy equals 1/4 the area in Planck units. For black holes, this means all the information is on the horizon, the event horizon surface, not in the interior volume, the surface, two-dimensional. The entire black hole's information content is determined by horizon area. This suggests the interior is redundant, not additional information, the same information as the horizon, just described differently. The interior is holographic projection from the surface, like a hologram. The 3D image is projection from 2D data, not separate, not additional, derived. Susskind realized this means falling into black hole doesn't take you to new region with new information. It changes your description of the horizon information. You're always describing the same degrees of freedom, the horizon, just from different perspective, different coordinates. The falling observer experiences interior because their world line is a certain path through space-time. Their description involves coordinates that include interior region. But those coordinates are describing horizon information in a particular way. The experience of interior is real to them. But the information content is the horizon, always was, always will be. The outside observer uses different coordinates, different description. Their coordinates don't include interior, only horizon. They see all information on horizon surface, see infalling matter spread out, thermalize, eventually radiate away as Hawking radiation, all without ever entering interior. Because there is no interior in their description, both descriptions have same information content, same degrees of freedom, same quantum state, just organized differently, represented differently, complementary descriptions of identical physics. This is black hole complementarity, and it's the only way to preserve quantum mechanics while respecting general relativity. It requires giving up the idea that interior is objectively real, independent of observer. Instead, interior is description-dependent, perspective-dependent, real to some observers, not to others. Both correct. Now here's where it gets truly shocking, because Susskind had to go further, had to answer how information gets out, how Hawking radiation carries information if it looks thermal. The answer is encoding. The information falling in gets encoded on the horizon. Holographically, then the horizon radiates. The Hawking radiation isn't pure thermal. It carries information. Encoded, scrambled, encrypted. But there. Preserved. But how? Hawking's calculations said the radiation is thermal. No information. How can both be true? Susskind's answer uses black hole complementarity again. From outside perspective, horizon has microphysics, microscopic quantum degrees of freedom, quantum hairs, microstates. These encode the information. The horizon is not smooth, not featureless. It has structure, quantum structure, too small to see, but real, essential. When Hawking radiation emits, it's entangled with these horizon microstates. The entanglement encodes the information. The radiation particles aren't just thermal. They're entangled with horizon. The entanglement pattern contains all the information about what fell in. From outside observer perspective, this is how information is preserved. The radiation carries it, encoded in entanglement, in correlations between radiation particles and remaining horizon microstates. From falling observer perspective, they don't see this. They see smooth horizon. They cross. They experience interior. They reach singularity. For them, information goes to singularity, gets destroyed. But their perspective is not complete. They're inside. They can't see the outside, can't see the information radiating out, can't see their own information being preserved on horizon. Both perspectives are partial, incomplete. Only outside observer sees full story, sees information preserved, sees quantum mechanics saved. But even outside observer doesn't see interior, because interior doesn't exist in their description, in their coordinates, in their reference frame. Now, Susskind has to prove this crazy idea actually works, because saying there's no interior is one thing, showing the mathematics is consistent is another, showing it matches observations is yet another. This took decades, multiple breakthroughs, collaboration with dozens of physicists. The first key was ER equals EPR. Einstein-Rosen bridges equals Einstein-Podolsky-Rosen entanglement. Wormholes equal quantum entanglement. This is Susskind's conjecture with Juan Maldacena, revolutionary, unifying geometry and quantum mechanics. The idea is simple but profound. When two particles are maximally entangled, they're connected by a wormhole, a microscopic Einstein-Rosen bridge. The entanglement is geometric, creates space-time connection. The particles are not just quantum mechanically correlated, they're geometrically connected through space-time. Apply this to black holes. The Hawking radiation is entangled with horizon microstates. Therefore, by ER equals EPR, the radiation particles are connected to the horizon by wormholes, microscopic wormholes, trillions of them, connecting every radiation particle to the horizon. These wormholes are the interior, the sum of all these microscopic connections. The web of wormholes connecting radiation to horizon. This is what creates the experience of interior for falling observer. They're traveling through this web, this network of quantum connections. But the wormholes are made of entanglement. They're quantum, not classical. They don't exist in any classical sense, only quantum mechanically, only as entanglement pattern. The interior is entanglement topology, not space-time geometry, not real space. Quantum correlation structure. This means interior exists as quantum description, as way of organizing entanglement, but not as region of space-time with independent degrees of freedom, not as place you can go with new information. Just as description of entanglement between horizon and radiation, Susskind calls this the holographic interior. It's holographically projected from horizon information. The horizon has n degrees of freedom. Some are in the black hole, some are in the radiation. They're entangled. The entanglement pattern can be described geometrically as interior, but it's not additional space. It's the same information, just organized geometrically. The firewall paradox tried to destroy this picture. In 2012, Almheri, Marolf, Polchinski, and Sully argued that black hole complementarity is impossible, that you must choose, either preserve information in radiation or preserve smooth horizon. Can't have both. Must have firewall at horizon, burning up in falling observers. Susskind fought this viciously, showed the argument makes assumptions that can be violated, that quantum error correction changes the game, that entanglement is more subtle than AMPS thought, that black hole complementarity survives if you're careful about quantum information. The key insight was quantum error correction codes. The horizon is not just storing information, it's protecting it, using quantum error correction, like quantum computers use. The information is redundantly encoded, spread across many microstates, error corrected, protected from local perturbations. This allows the same information to be described multiple ways. The code has logical qubits and physical qubits, different descriptions, different ways to organize same information. Some descriptions have interior, some don't. All are valid. All describe same protected quantum information. This is how complementarity works. It's not magic, it's quantum error correction. The horizon is quantum error-correcting code. The interior is one logical description. The horizon plus radiation is another logical description. Both encode same information. Both are valid. Both are complementary. Hawking eventually conceded, accepted that information is preserved, that quantum mechanics wins, that black holes don't destroy information. Susskind won the war. But the victory is strange, because what he proved is that black holes are even weirder than anyone thought. There is no interior in the objective sense, only an observer-dependent sense, only as description, as perspective, as way of organizing information, but not as independent region of space-time, not as place with new degrees of freedom, not as real interior. Now, ADS-CFT makes this even more explicit. The anti-de Sitter conformal field theory correspondence, Maldaceno's duality. Gravity in bulk equals quantum field theory on boundary. In ADS-CFT, black hole in bulk is described by thermal state and boundary theory. The boundary theory has no interior, no graviton, no geometry, just quantum field theory, matter fields, interactions, no space, no interior, nothing. Yet this boundary description is exactly equivalent to bulk description with black hole interior. Same physics, same information, same predictions. How? Because the interior is emergent. It emerges from entanglement in boundary theory, from how boundary quantum states organize. The interior doesn't exist in boundary theory, exists only in bulk description. But bulk is derived, emergent, holographic projection from boundary. So interior is emergent, not fundamental, appears when you project boundary information into bulk geometry, but not there in fundamental description. This proves Susskind's point. Interior is description dependent, exists in some descriptions, not in others, all describing same fundamental quantum information, same degrees of freedom, same physics. Now the philosophical implications are staggering. If black hole interiors are observer dependent, what else is? What other aspects of spacetime are description dependent, not objectively real, just perspectival? Susskind argues all of spacetime is like this. All geometry is emergent, holographic, description dependent. Space itself doesn't exist fundamentally. Only quantum information exists. Only entanglement. Only Hilbert space dynamics. Space is how this information looks when you organize it geometrically. But the geometry is derived, perspective, description, not fundamental reality. The end of inside, not just for black holes, for everywhere. There is no inside fundamentally, no interior, no regions, only information, only quantum states, only entanglement patterns. Everything else is emergent, description dependent, observer dependent. This is the deepest lesson of black hole complementarity. Not just about black holes, about reality, about space, about what exists and what's merely how we describe what exists. You think you're inside a room, inside a building, inside Earth's atmosphere, inside the solar system. All these insides are classical approximations, useful descriptions, emergent organization of quantum information, but not fundamental, not really there in deepest sense. What's really there? Quantum information, entanglement structure, Hilbert space states. The insides are projections, holographic appearances, ways of organizing information geometrically, real in their effects, real in their usefulness, but not fundamental, not ultimate reality. Susskind spent 30 years proving this for black holes, fighting Hawking, developing complementarity, discovering holography, understanding quantum information, all to show that interior doesn't exist in the way we thought. But the implications extend infinitely. If black hole interior is emergent, observer-dependent, holographic, then so is everything. All of space, all geometry, all of physics as we know it. This is why the black hole information paradox mattered so much. Not just about black holes, about the nature of reality, about what's fundamental and what's derived, about the end of inside, the end of geometry as fundamental, the beginning of quantum information as ultimate reality. Hawking tried to break quantum mechanics, Susskind defended it, won. But the victory required sacrificing space-time, showing it's not fundamental, showing geometry is emergent, showing inside is illusion. The cost of saving quantum mechanics was losing classical spacetime, but Susskind pays this cost gladly because quantum mechanics is sacred, is tested, is proven, is the bedrock, while spacetime, derived, approximate, emergent, real at large scales, but not fundamental, not ultimate. Black holes taught us this, taught us through information paradox, through complementarity, through holography, through 30 years of debate, through Susskind's stubborn refusal to give up quantum mechanics, through his willingness to sacrifice intuition, to sacrifice inside, to sacrifice geometry itself. And what did we gain? Understanding, deep understanding. That reality is quantum information, that space is hologram, that inside is perspective, that black holes are quantum error-correcting codes, that complementarity is real, that observers matter, that descriptions matter, that there is no objective interior, no objective geometry, only quantum information and how we organize it. This is the end of inside, not just for black holes, for reality, for physics, for our understanding of what exists. Inside was never real, was always description, always perspective, always emergent. And now we know, thanks to Leonard Susskind, thanks to black hole complementarity, thanks to holography, thanks to the war he fought and won, there is no inside. There never was. The black hole interior you imagine doesn't exist. The infalling observer's experience is real to them. But it's not objective, not fundamental, not a region of space-time with independent existence. It's description, perspective, holographic projection, real in its way, but not in the way you thought, not as place, not as region, not as inside. Welcome to physics without inside, where everything is surface, where information is fundamental, where geometry emerges, where black holes teach us that reality is stranger, more subtle, more quantum, more beautiful than classical intuition ever imagined. The end of inside, the beginning of understanding, the triumph of quantum mechanics, the victory of information over geometry, the proof that reality is not what it seems, that space is not fundamental, that inside is illusion. Leonard Susskind proved it, spent his life proving it, fighting for it, defending quantum mechanics at all costs, even the cost of inside, even the cost of geometry, even the cost of our intuitive picture of reality. And he was right. The information paradox is solved. Quantum mechanics is preserved, black holes are understood. And the price? The end of inside. The realization that we were always wrong about what black holes are, about what space is, about what exists. But this price is not too high, because truth matters, understanding matters, and now we understand. Black holes have no interior, never did, never will. The inside was always illusion, always description, always observer-dependent perspective on information that's always on the surface, always holographic, always quantum. This is the truth, the brutal, beautiful quantum truth, and it changes everything.